So let's look at problem number 4. We want to compute the projection of B onto the space spanned by A0, A1. First thing we need to do is construct a matrix A that describes the space spanned by A0, A1, and that matrix is going to have two columns where the first column is 1, 1, 0, and the second column is 1, 0, 2. And we know a formula for finding the projection of B onto the space. It's given by A times A transpose A, quantity inverse, times A transpose B. So all we need to do is find out the pieces. I'll first figure out what A transpose A inverse is. I'll determine A transpose B. I'll multiply these, and then I'll multiply by A. That's my strategy. So first, A transpose A is the matrix product of 1, 1, 0, 1, 0, 2 with 1, 1, 0, 1, 0, 2 as columns. And the product will be, it's a 2 by 3 times a 3 by 2. It will be a 2 by 2 with entries 1 squared plus 1 squared plus 0 squared is the first entry. And then the entry here is going to be the first row times the second column, which turns out to be 1 times 1 plus 1 times 0 plus 0 times 2, or 1. This will be the second row times the first column, which again is going to turn out to be 1 times 0 plus 0 times 1 plus 2 times 0, which is 1. And then the last entry here is going to be 1 squared plus 0 squared plus 2 squared, which is 5. Last problem, we found the inverse of a 2 by 2, first by finding the determinant. And the determinant for this is going to be 2 times 5 minus 1 times 1, which is 9. So it's going to be 1/9 for our 1 over the determinant factor in our inverse. And then what we need to do to find the inverse is switch the 5 and the 2 and negate the 1. So this is A transpose A inverse. Now, what is A transpose B? It's the matrix 1, 1, 0, 1, 0, 2 times the vector 0, 1, 1, which will be a vector with entries 1 times 0 plus 1 times 1 plus 0 times 1, which is 1, and 1 times 0 plus 0 times 1 plus 2 times 1, which is 2. So now if I take A transpose A inverse times A transpose B, it means I multiply 1/9 times the matrix with entries 5, -1, -1, 2, to the vector with entries 1, 2, and the result is going to be the vector 1/9 times 5 times 1 plus -1 times 2 is 3. -1 times 1 plus 2 times 2 is again 3. So it actually is the vector with components 1/3, 1/3. Now, I'm supposed to, in order to find the projection, multiply this by A. So that means I take the matrix with column 1, 1, 0 and column 1, 0, 2 and multiply it by 1/3, 1/3, and the result is going to be the matrix with, the vector with entries 1/3 plus 1/3 or 2/3, 1/3 plus 0, and 0 plus 2 times 1/3, which is 2/3. So this will be the projection. Now the second question is compute the linear least squares solution to find the approximate solution of ax plus b. Well, I recall the formula for that is that the approximate solution is x is A transpose times A, quantity inverse, times A transpose times B, which we already determined was the vector 1/3, 1/3. So we're done.